Hi guys, it's Tayyib Shah. Today I have Ethan with me, and he's a master's student at the University of Saskatchewan. And he's doing very interesting research using a remote sensing technology. So let's start our conversation with her. Welcome, Ethan, in my
Thanks.
channel.
Thank you for having me.
Okay. So would you like to introduce yourself?
Sure. Hey everyone, I'm Ethan Bowes. I'm a Master of Science student here at the University of Saskatchewan, and I work in the Department of Mechanical Engineering, kind of on precision agriculture technology. So I use remote sensing for farming applications.
Okay, interesting. Thank you. So, would you like to explain what exactly your research program or research objectives are?
Sure, yeah. We're looking at developing a sensor technology kind of to classify and identify locations where diseased wheat is in or present in fields. This will allow for some selective harvesting and variable rate spraying technologies, or improving the quality of grain and just increasing the food stability overall. So we're using remote technologies and multispectral instruments to try and classify and identify a disease called fusarium head blight, which is a fungal disease in wheat, and it can cause any wheat harvested with concentrations of this disease to be inedible for humans and animals, kind of causing the overall grain quality to go down.
Okay, so very interesting research idea. So, how exactly you are going to be design your research project, and how going to be use geospatial technologies in that area?
For sure. So right now we're just prototyping some multispectral cameras to try and get clear identification of this disease. We're going to be testing it out on some carts, just flying over some imaging plots. And then once we have that validated, we're seeing can we effectively classify where this disease is located. Then we're going to try and upgrade it to a field level application, which would be using remote sensing and drone technology. So you can mount the instruments we're building, which is just multispectral cameras for specific use in this area. And then you can use some remote sensing and mapping technology over fields to kind of see, are there any identified disease locations, and kind of plot them out so you can either avoid them when harvesting, or if you need to apply like fungicide or something, you can, instead of just blanket spraying the whole field, just focus on the one specific disease location.
Okay, so it means you're developing your own sensor, or you using an existing one? What's the main?
Yeah, so we're developing our own sensors here. It involves kind of creating optic paths and stuff. So we use an RGB camera as well as two monochrome sensors to get extra bands as well. And we have a default Canon lens we're actually using for the prototype. And then that goes through some optic beam splitters and dichroic mirrors, and then through some light filters to get the specific areas of reflectance that we're looking at. And then each specific reflectance we're looking at goes to its own individual monochrome filter, and then that's all processed through our pre-built like computer board system. So somewhat custom-made hardware, and it'll be used to prototype, and then we'll have to make some adjustments and kind of scale it up for the field.
Very interesting. So after building this sensor, so how many times you planning to collect the data, and do you have any plan to do data processing? Because it looks like very you need a specific kind of software or tools, or maybe you have to develop something. So what is your plan? Would you like to share with us?
Yeah, sure. For data collection, we're starting in the high tunnels at the University of Saskatchewan. Here we have a greenhouse system where they have like individual plant pots, and then that will be our very first test. So we'll be imaging that for about a month starting in July, and then we're going to make some tweaks to make sure we can identify the right things in the plots, and then we'll be moving out to the field on a cart just to drive over. We've got some pre-disease inoculated plots, and those will be imaged again just with some tweaks and stuff. All the data imaging will just be done kind of separately from processing. So just during these summer months here, we'll be doing the data collection, and that'll just be gathering the images with the multispectral camera that we've created. And then processing will be done separately kind of after, beginning in September. And that will be using mostly custom software and image processing techniques. So we'll be trying to develop something application specific to identify like these diseased wheat heads. And that, yeah, it'll involve a lot of like machine learning based methods, and then once that is all kind of created, we'll hopefully have it to just a pipeline process where the images can automatically go through and get detected, or the disease can get detected.
Very interesting, very interesting. So you're using diverse kind of techniques,
Yes.
spending some time in designing a sensor, building your own sensor, in other words, and the whole equipment.
Yes.
And then finally you moving towards the data analysis. It's a very interesting thing. So would you like to share your thoughts or some advice to the students who really want to do these kind of things? What are the critical things in this project you think it's good to share with other leaders?
Yeah, there are just a lot of areas you can have a pretty big impact here in Saskatchewan. Agriculture is one of our kind of strong suits here, and food security is just always a place that there can be improvement and stuff like that. So if you find an issue and you're passionate about it, you can generally find some areas that you can improve it, and like even small changes like this can end up having a large like economic and environmental impact over long periods of time. So just identifying certain things that you're interested in, and then kind of just thinking about who can solve it, what kind of technology could we apply here. There are plenty of new, even like specifically software related things like machine learning that haven't been applied to a lot of problems, and I know there's plenty of potential there. So yeah, just try and find something you're interested in there and kind of apply what's already been out there to some new problems.
Okay, thank you very much, Ethan. It's a very nice talking with you, and hope you will, once you finish your project, we will have a chance
You
to
bet.
learn what your findings are. Thank
Awesome.
you very much for your time.
Thank you for having me.